All right, thanks for tuning in. Somebody asked me a question the other day about their expected output for their solar array. They went up on the roof, took some measurements, realized how many modules they could fit, and they just want to get an idea on how much they can expect for output. This is a really quick, back of the envelope calculation that you can use on your own. You can do this all over the world, frankly, and I'll tell you where to change the calculations depending upon where you live. We do have to have a couple of assumptions, though. We're using 250 watt modules. If you're using a different number, change that. Where it says 250, just change that figure. We're putting up 12, same type of a thing. If you can fit 10, change that number. We're in Pennsylvania. That's about sun hours per day. Basically, National Renewable Energies Laboratory wants to account for the different amounts of sun in different parts of the country that we get. Obviously, Pennsylvania is a different amount of sun than California or New Mexico or even Alaska. So we want to account for that. And the number we use in Pennsylvania, I usually use is 4.2 sun hours per day. California might have 6. Some parts of New Mexico even has higher. And that does change. So you can look that up, and we'll try and put a link to the website. And then we have 20% losses. It's a pretty easy standard figure to use, and we'll show you why. Those losses, they can be for a lot of different reasons. Anytime any electrical components are connected together, you're going to have a little bit of a loss. Anytime you use an inverter, you're going to have a little bit of a loss. The modules have a little bit of a loss. They might be a little dirty. You just want to account for that in your calculations. All right, so we're going to start at, first of all, 250 watts. All right, so 250 watts times 12, number of modules, times 0.8. We can only use 0.2, so 0.8 is what is left. I'm sorry, we lose 0.2, 20%, so we have that amount left. Then we're going to put in this 4.2 hours per day in this calculation. So from all of that, we get 10.00 watt hours per day. All right, so that's our actual uses, but no one actually talks in watt hours per day, right? We always talk in kilowatt hours per day. So we're going to go ahead and we're going to call this 10 kilowatt hours per day. All right, so if we look there, so we have 10 kilowatt hours per day. That's what we're getting. But what if you want to know how much you're getting per year? Pretty simple. I'm sure you can probably see where this is going. 10 kilowatt hours per day. You want to multiply that times 365. I'm sorry, we'll make it real official. Days per year. And that's going to give us 3, 6, 7, 9 kilowatt hours per year. All right, so this is a number that you're going to be able to use a lot of, and you should use a lot of, frankly. This is a number that, with this size of array, 3,679 kilowatt hours per year, is you can look at your bill. You can say, oh, that's 20% of what I use per year. It might be 10% of what you use per year. What your expected needs are, or if somebody's charging you to put solar on your own roof, you can use that number and see if you've got something close, and ask them some questions if you feel like it's not necessarily accurate, or they're giving you maybe some different inflated figures. But all right. Thank you very much. If you have any questions, please feel free to post or ask some questions, or email me directly. Thank you.